In the year 132 AD, something incredible happened in ancient China. A bronze device, no bigger than a large vase, sat silently in the imperial palace. It had no wires, no batteries, no modern technology at all. Yet this mysterious invention could detect earthquakes hundreds of miles away, sometimes days before anyone felt the ground shake beneath their feet. Today, this remarkable machine has been almost completely forgotten by the world. Most people have never heard of it. Even many scientists dismiss it as ancient mythology or primitive superstition. But what if they are wrong? What if our ancestors possessed knowledge about predicting earthquakes that we have lost forever? The device was called the seismoscope, and it represents one of humanity's first attempts to understand and predict one of nature's most destructive forces. For over 1800 years, this bronze marvel remained operational, saving countless lives by providing early warning of approaching earthquakes. Then suddenly, all records of how it worked vanished from history. The knowledge was lost, buried beneath centuries of political upheaval and forgotten wisdom. But here's what makes this story truly terrifying. Modern seismologists, with all their advanced computers and satellite technology, still cannot reliably predict when an earthquake will strike. They can tell us where earthquakes are likely to happen, but not when. Meanwhile, historical records suggest this ancient Chinese device was doing exactly that nearly 2,000 years ago. The seismoscope looked like a large bronze jar about 6 feet wide, decorated with dragons and mythical creatures. 8 dragon heads were mounted around the top, each holding a bronze ball in its mouth. Below each dragon sat a bronze toad with its mouth wide open, waiting to catch the ball if it fell. The entire device was perfectly balanced on a central pendulum mechanism hidden inside the bronze casing. When an earthquake occurred anywhere within a radius of several hundred miles, the ground vibrations would travel through the earth and reach the seismoscope. These vibrations, too small for humans to feel, would disturb the delicate internal mechanism. One of the dragon heads would open its mouth, dropping its bronze ball into the waiting toad below, with a loud clang that could be heard throughout the palace. The direction of the earthquake was indicated by which dragon dropped its ball. If the dragon facing north released its ball, the earthquake had occurred somewhere to the north. Palace officials would immediately send messengers on horseback to investigate and provide assistance to affected areas. Often these messengers would arrive at disaster zones before local authorities even knew an earthquake had happened. Historical accounts describe the seismoscope's accuracy as nearly perfect. Court records document numerous occasions when the device detected distant earthquakes that were completely unfelt in the capital city. Skeptical officials would sometimes doubt the machine's warnings, only to receive confirmation days later when reports arrived from remote provinces describing devastating tremors. The most famous recorded incident occurred when the seismoscope indicated an earthquake to the west, but no one in the capital felt anything. Court officials began to question whether the device was malfunctioning. However, several days later, messengers arrived from the western provinces reporting a major earthquake that had destroyed several towns and killed hundreds of people. The seismoscope had detected the disaster from over 300 miles away. What makes this achievement even more remarkable is that the inventor created his seismoscope without any understanding of modern seismic theory. He didn't know about tectonic plates, seismic waves, or the scientific principles that govern earthquake propagation. Yet somehow, through careful observation and brilliant engineering, he managed to create a device that functioned on the same basic principles used by today's earthquake detection systems. Modern seismographs work by detecting the primary waves that travel faster than the more destructive secondary waves that cause the actual shaking people feel. The ancient seismoscope appears to have worked on a similar principle, responding to these initial vibrations that arrive before the main earthquake shock. However, despite numerous attempts by modern engineers and historians, no one has been able to successfully reconstruct a working replica of the original seismoscope. The detailed specifications and internal mechanisms were never recorded, and the original device was destroyed during political upheavals centuries ago. All that remains are vague descriptions in historical texts and artistic depictions that lack technical detail. Some scholars argue that the seismoscope never actually worked as described, claiming that the historical accounts were exaggerated or fabricated to glorify ancient achievements. They point out that detecting earthquakes from hundreds of miles away would require extraordinarily sensitive instruments, far beyond what ancient metallurgy and engineering could produce. But other researchers disagree strongly with these skeptics. They note that ancient Chinese engineers accomplished many seemingly impossible feats, from building massive irrigation systems to creating mechanical clocks centuries before similar devices appeared in Europe. The precision of ancient Chinese metalworking and their advanced understanding of mechanical principles make the seismoscope's existence entirely plausible. Archaeological evidence also supports the device's authenticity. Fragments of bronze dragons and toads have been discovered at sites associated with ancient Chinese palaces, and these artifacts match descriptions of seismoscope components found in historical texts. Additionally, similar earthquake detection devices were developed independently in other ancient civilizations, suggesting that such technology was indeed possible with ancient materials and techniques. The loss of seismoscope technology represents more than just a historical curiosity. It highlights a troubling pattern in human civilization where valuable knowledge gets lost during periods of political chaos or cultural upheaval. Libraries are burned, scholars are scattered, and technological innovations disappear forever. This pattern continues today. Modern earthquake prediction remains one of science's greatest unsolved challenges. Despite decades of research and billions of dollars in funding, seismologists cannot reliably predict when earthquakes will occur. They can identify areas at high risk and estimate probabilities over long time periods, but short-term earthquake prediction remains impossible with current technology. The consequences of this limitation are devastating. Major earthquakes continue to strike without warning, killing thousands and causing billions of dollars in damage. Recent disasters in Turkey, Syria, Japan, and Haiti have demonstrated our continued vulnerability to seismic events. Each tragedy raises the same haunting question: could we have saved more lives with better earthquake prediction? Meanwhile, animals continue to display strange behaviour before earthquakes, suggesting that natural early warning systems still exist around us. Dogs bark frantically, horses refuse to enter barns, and snakes emerge from hibernation in winter. These phenomena mirror the sensitivity that the ancient seismoscope apparently possessed, detecting subtle environmental changes that precede major seismic events. Some modern researchers are now taking a fresh look at ancient earthquake detection methods, wondering if our ancestors understood something about seismic prediction that modern science has overlooked. These scientists are stepping away from their computer screens and laboratory equipment to study dusty historical texts and oral traditions passed down through generations. They're examining folk wisdom from Japan, where fishermen claim their nets behave strangely before earthquakes. They're investigating Native American stories about animals fleeing before the earth shakes. They're analysing ancient Greek writings that describe wells changing their water levels days before major tremors. In China, teams of engineers are working with historians to decode the lost secrets of the seismoscope. They've built dozens of test models, each one slightly different, trying to recreate the sensitive internal mechanism that made the original device so effective. Some attempts have shown promising results, detecting distant vibrations that modern equipment missed. But none have matched the legendary accuracy described in ancient records. Other researchers are studying earthquake-sensitive animals, wondering if they possess natural abilities that ancient people learned to interpret. Recent studies have documented unusual behaviour in farm animals, pets and wild creatures before major seismic events. Dogs become restless and bark continuously. Cats hide in strange places. Horses refuse to enter their stables. Hibernating snakes wake up and crawl out into freezing weather. These patterns suggest that animals can sense something humans cannot detect with their natural senses. The timing of this research couldn't be more critical. Seismologists warn that several major earthquake zones around the world are overdue for catastrophic events. The San Andreas Fault in California hasn't produced a major earthquake in over 150 years, creating enormous pressure that must eventually be released. The North Anatolian Fault in Turkey continues to show dangerous activity after recent devastating quakes. The Cascadia subduction zone off the Pacific Northwest coast could generate a magnitude 9 earthquake that would affect millions of people. The Pacific Ring of Fire remains particularly active, with increased seismic activity recorded in recent years. This horseshoe-shaped zone of earthquake and volcanic activity circles the Pacific Ocean, affecting countries from Chile to Japan. Recent major earthquakes in this region have killed hundreds of thousands of people and caused billions of dollars in damage. Densely populated cities like Los Angeles, Tokyo, and Istanbul sit directly on major fault lines, with millions of residents potentially at risk from future seismic disasters. Scientists are also discovering that human activities might be triggering more earthquakes than ever before. Deep drilling for oil and gas, massive construction projects, and the filling of large reservoirs behind dams can all disturb underground rock formations. Some areas that rarely experienced earthquakes in the past are now seeing regular seismic activity linked to these human interventions. Climate change may also be affecting earthquake patterns, though the connections are still poorly understood. As ice sheets melt and ocean levels rise, the changing weight distribution on Earth's crust could trigger increased seismic activity in unexpected locations. Melting glaciers remove enormous weight from some areas while rising seas add weight to others. This redistribution of mass might be awakening fault lines that have been quiet for centuries. The ancient Chinese seismoscope reminds us that innovation doesn't always move forward in a straight line. Sometimes the most advanced civilizations lose crucial knowledge that their ancestors possessed. The Library of Alexandria burned, destroying countless ancient texts. The Maya abandoned their cities, taking their astronomical knowledge with them. The Romans forgot how to make their incredibly durable concrete. Sometimes the answers we desperately need are hidden in the wisdom of the past, waiting to be rediscovered by those humble enough to look backward while moving forward. Today, as we face an uncertain seismic future with imperfect prediction tools, perhaps it's time to look backward as well as forward. The bronze dragons and toads that once warned of approaching earthquakes may hold secrets that could save lives in our modern world. But first, we must find the humility to learn from those who came before us, and the wisdom to preserve the knowledge we discover for future generations. The seismoscope stands as both an inspiration and a warning. It shows us what's possible when human ingenuity meets careful observation of natural phenomena. But it also reminds us how easily such achievements can vanish, leaving us more vulnerable than we need to be in an unpredictable world. The race is on to rediscover these lost secrets before the next great earthquake strikes.